Hi, I'm Zahra Ashktorab, and I'm here to present the work we did on AI-assisted human labeling, batching for efficiency without over-reliance. Labeling trading data has imposed a bottleneck on machine learning tasks. It's a required step to train supervised machine learning algorithms, but it can be both time-intensive and expensive. Crowd workers and subject matter experts must use their cognitive abilities to categorize and label large data sets, which is often a repetitive process. Labelers could benefit from a tool that would make their tasks more efficient and less laborious. In this project, we studied batch labeling, where a single label action can be applied to multiple records, as seen here. On the left-hand side, we see 4 items that should be assigned the same label. In order to compute fixed-size coherent batches, we use an unsupervised nearest neighbor inspired data partitioning algorithm. The algorithm produces batches based on computing an n by n nearest neighbor matrix, where n is the total number of data items. The nearest neighbor batching algorithm relies on the smoothness assumption commonly applied in supervised and semi-supervised machine learning that states that points that are close to each other in the feature space are more likely to share a label. We addressed a series of research questions in this paper and divided them up as studies. We first start by discussing the accuracy and speed of batching in the first place and how task complexity can impact the outcome of data labeling. We then look at how the feedback given to the labeler about the AI's involvement impacts the outcome. And then we look at over-reliance and how the quality of the batches impacts the degree to which users over-rely, as well as looking at mitigating the over-reliance in study 4. We recruited 165 participants from Mechanical Turk, and after integrity checks, we had a total of 150 participants. The dataset consists of 240 utterances and 12 unique labels, each example having a single label with a balanced distribution across labels and a set of utterances. This dataset was selected due to its general domain accessibility for non-specialists and realistic use case. The table shows the 12 original labels and their definition that belong to 2 categories. And for the purposes of our study, we also derived a simpler categorical labeling of the data where each example pertains to either banking or telecommunication and phone services, as seen in the 2 rows that are labeled as vocab size equals 2. So our first 2 questions in study 1 was around how much does batching impact the outcome of the labeling task, and how does task complexity impact the outcome of data labeling? We had various conditions. As you can see up top, it's the complex task and the batching condition. And then the bottom image shows a simple task and no batching condition. We found that participants were significantly faster in the batching condition than the no batching conditions. We also found that participants in the less complex task, vocab size equals 2, were much faster, unsurprisingly. But one of the interesting findings was that users were not more accurate in the batching condition. In fact, there was no significant differences for accuracy. We were also interested in whether telling users that the batches are generated by an AI system impact the outcome of the task. Automation bias is defined as the tendency to over-rely on automated systems. And this issue has been investigated in a number of critical industries, such as medicine and aviation. In a situation of over-reliance, humans uncritically follow recommendations from an automated system without using their own judgment. And this can be harmful because it degrades human-in-the-loop processes, where the human plays an important role in providing feedback. For the purposes of our study, we were able to operationalize agreement and over-reliance. Agreement was the count of agreement with batching that 4 items in a batch get assigned the same label, regardless of whether they should be assigned the same label. And we define over-reliance as the count of agreement with batching that 4 items in a batch get assigned the same label, and they should not be assigned the same label. We added an additional condition in study 2, in which we were investigating how this messaging would impact the outcome. Here we have written up top, the AI system thinks these items should have the same label. We found that users over-relied more on the system when they were given this feedback about the source of the batching, rather than when they not provided the information. In study 3, we were specifically looking at over-reliance on the quality of the batches. Now, we were using a baseline AI throughout the study, but what if we varied the different AIs that were generating the batches and introduced a degradation AI and a perfect AI? So the degradation AI, as you can see in this graph here, the quality of the batches decreases over time as the user is labeling. For the perfect AI, we had the gold standard values, so we were presenting perfect batches to users for every condition. Of course, with the definition that we have for over-reliance, it's impossible to over-rely on the perfect condition because every 4 items in a batch should be assigned the same label. But we did find significant differences between degradation and baseline and the perfect AI for degree of over-reliance. In study 4, we were asking, can we mitigate over-reliance on AI-assisted batching by asking users to rate the batches suggested by the AI system? We were also asking if we can mitigate over-reliance on AI-assisted batching by signaling to users that their responses will help improve the AI's batch recommendations in the future. These were the 2 mitigations that we provided to users. In this mitigation, the one pictured above, we informed users that they were collaborating with the AI system to recommend better batches. Users were told your labels will help train the AI system to recommend better batches. In the rating mitigation, as seen below, users were informed that the quality of batches would be rated at the completion of the study, signaling that the AI is not perfect. Users were notified that you will be asked to rate the AI on the quality of these batches in a survey. While we did not find any significant differences for over-reliance for these 2 conditions, we think that there still can be additional work done on looking at over-reliance in AI-driven systems and mitigating over-reliance. We also collected open-ended responses at the end of the task. Users reported, the system was more advanced than I thought, or the recommendations were mostly related with the label, so it was very helpful. Only in a few cases I had to change it. Users also noted that the complex tasks confused users because there were too many categories to choose from, and also at first the idea of doing 60 groups in a row seemed like a lot, but it ended up being a lot easier and more efficient than I expected. Based on our findings, we can provide some design recommendations. First, select all functionality should only be used if there's certainty around the similarity of the batches. In fact, if the 4 items in a batch should not be assigned the same label, it requires more clicks to go through and deselect the items if they've been pre-selected all. So that should only be happening if there's certainty around the quality of the batch. For batching systems with varying sizes, the number of items recommended in a batch should depend on the similarity of items in the batch. We had fixed sizes that we were providing to users, and part of that was to be consistent and not to overwhelm users in providing various batch sizes. But we did find that users were complaining that why there would be 4 items in a batch if they didn't belong together in the first place. So that's another consideration for future work. We also found, while we weren't able to mitigate the over-reliance, feedback impacts performance, letting users know that the suggestions were a result of the AI, impacted how much time users spent completing the task. And we also found that while we were providing perfect batches to users, it didn't yield perfect scores. In fact, if users mislabel a perfect batch, they're still mislabeling 4 items. So in the future, label suggestions may help. With some additional AI assistance, the system could recommend the label that should be assigned the batch. Thank you for your time. I'll take questions now.